This is Lucerne Geometry, Unit 2, review number 2. And I'm going to look at in this video numbers 1, 2, and 3. They're all kind of dealing with similar topic. They're all dealing with these congruent triangles from transformations. So for number 1, it says for each of the pairs of triangles below, describe the transformation that will create congruent triangles. And remember, by transformation they mean either reflection, translation, or rotation. And it says draw in the line of reflection, point of rotation, or the movement of the translation. So first we have to decide on what move it is and then where that move is happening. For part A, we've got our two triangles. Now initially you would look at that, a lot of people think it's just going to be a reflection. A lot of times when these triangles are overlapping, they're sharing that side, you think, oh, I'm just going to flip it over and it's going to work. But bring in our trusty tracing paper. I'm going to draw this. I'm going to trace this triangle. There's my 2 dashes and 1 dash. So if I do reflect it, if I flip that over, notice that when I flip it, the 1 dash, we want the dashes to be matching up. We want the single dash on the single dash, the double dash on the double dash. On this one with the reflection, the single dash is going with the double dash, which is not matching up. That's not what we want. So instead of reflection, what I'm going to do is I'm going to turn it and rotate it, and now I've got the single and the doubles matching up. Now since it was a rotation, that's one answer, just the right rotation. And when I rotated, I spun around that point in the middle of the line, so I'm going to draw that point that I spun on. So there's part A for rotation. For part B, now I'm trying to figure out how to get this first triangle down here, and tracing it again. It doesn't look like it's going to be a rotation. Notice that they're both facing the same way. They both got this arc, this angle up top. The single dash, double dashes are both kind of in the same place. So if I reflect it, it's going to be backwards. I'm not going to rotate it, it's going to be upside down. But if I translate, if I slide to the right and down, there it matches up. So translation. Now I'm just going to draw arrows showing that it translated to the right and down to get to that new one. Part C, same idea, tracing this one on the left. And now notice that when you compare the ones on the left and right, now they're upside down. So it might be a reflection. If I reflect it, do that, and notice they're not matching up again, same as part A. So if I rotate, I want to try to make sure, again, when I turn, there's my rotation, and there it ends up right there. So notice that point was kind of in the middle, right between the two triangles. So I'm going to put a point right here, and again, that was rotation for part C. For number 2, which triangle congruence theorem is shown in the example below? So we don't necessarily have to worry about moving it, although moving it will help. But for the triangle congruence theorem, remember that those theorems are SSS for side, side, side. SAS, side angle side. ASA, AAS, and HL for hypotenuse leg. And right off the bat, we don't have any right angles. They're not right triangles, so it's not going to be HL. We don't have all side lengths. There's no marks on these other sides. There's no numbers, so it's not going to be SSS. So if we look at what they've given us, I'm going to look at just this one triangle by itself. The 53 degrees is an angle, so I'm going to put an A for angle. The 12 is written on the outside. That represents a side length. The 43 degrees represents an angle. There's my A for angle. So now when I look at just this one triangle, if I go in order, A, S, A, there's my congruence theorem. So it's got to be ASA. And if you look at the other triangle, you've got the 53s matching, the 12s matching, the 43s matching. So it goes in the same order, angle, side, angle. Last one for this video, number 3. In triangle GHJ, there's triangle GHJ, the one on the top. And triangle GKJ, it is given that side HG or segment HG is congruent to segment KG. So if we find those two first, HG, there's HG, KG, I'm going to put a dash on each of those to show that those are the same. And JH, there's JH, is congruent to JK. So now we've got two pairs of sides marked. The one pair that's missing is this side in the middle. They share JG. That's reflexive property where they both have that side in the middle. It says, which rigid transformation validates the SSS criterion for triangle congruence? And basically what they're asking is, like in number 1, there's some move that gets the first triangle up top onto the second triangle on the bottom. This is one, in number 1, remember A, B, and C, there was no reflections. There were 2 rotations, there was a translation. This is now the time when we're using reflection. So just to check, just to see the visual, whoa, I'm tracing the triangle up top. There's 3, 1, and 2. Now if I flip this triangle upside down, I'm flipping over this line in the middle. Now see how it matches up. So here, this is a good example of when reflection works. So it's not rotation. There's reflect. More than one transformation is necessary. Reflection is the only one that we needed. It's not translation. It says reflect triangle GHJ, which is your top triangle, over JG. That's the one we want for number 3.